In this tutorial we're going to look at the hole command in Inventor. This command is also particularly useful as other commands, as it allows for threading of certain components, the incorporation of certain pivots and pins to allow for assembly, and also during the design process for the actual end assembly of a final product. And the first thing I'll do here is just go to draw a simple rectangle. I'm going to extrude it upwards, and then I'm going to show the creation of the hole using the toolbar on the top of the Inventor interface. So I'm in a simple block there. I'm just going to create a 2D sketch on the top so as to locate the hole in a certain position. So I'm just going to say that this rectangle here, on the end of this, I want to create a hole. So I just finish the sketch, pick the hole button from the top of the toolbar, and as soon as this is clicked, a dialog box comes up. I'm just going to pick my spot there to put the hole first. Now in this dialog box I get many different options about the hole type and specifications that I want to incorporate. But first of all I'm just going to go to the simple elements, the hole depth for the countersunk, if any, the actual diameter of the hole, the termination that's going to be created in the model, the drill point, if it's going to be flat or countersunk, and as it's changed you can see it representing itself in the drawing also. So if you change the angle, you can see the top angle of the countersink actually changing in the drawing as well. So there's a simple hole, there's a clearance hole. So in the clearance hole it allows for different specifications. You have different DIN and SIO standard. You have the fastener type that you may want to use in the actual assembly process, and this can be incorporated into the threading as well. The size of the hole, and the fit, if it's going to be close, normal or loose. So these can be changed by using the simple drop down menu. The next one here is the tapped hole, and then you get the thread type options. So you can go for full depth, left-handed thread, right-handed thread, thread types as shown here, the actual size. You can go for different specifications, and the class. Finally, there is a tapped hole, a taper tapped. You can once again go for thread type. And even though these tutorials deal primarily with furniture construction in the wood industry, there's often times there's metal components incorporated into furniture design, and it's very efficient and very good practice to allow the designer of the actual furniture itself to be able to represent to perhaps an outside manufacturer of steel or flat components the actual specifications they want, so that there's no errors when it comes to actually assembly process and during the design stage itself. So I'm going to go back to the normal hole here. That's the representation on the model. Just click OK. So now this hole has followed the specifications as was input in the dialog box for the hole command. And as you can see, the hole didn't come out through the block as we had set specifications to stop short. You can just go back in the hole again, and if required you can actually move the feature by simple drag and drop. I can now edit the feature again, and I can pick from a large variety of constraints here and specifications. I can actually create certain distance here now again, so I can put it through all, and I'll be utilising a flat tipped bit. And I can go full depth, And now the thread is created on the inside of the hole. And this is set up in the exact specifications that are required, that are set up in the dialog box. Now you can see as well, the hole is mounted at the bottom and the thread is full depth. Back into edit the features. I can now select other types if I require.